Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class, our dear student. I hope you are doing well and are ready to explore another exciting property of elements and the periodic table. Let me start with that. My dear student, have you ever wondered why non-metals like chlorine and oxygen are so eager to accept electrons? My dear student, the answer lie in a property called electron affinity. My dear student, a concept that helps us understand how easily an atom can accept an electron to form a negative ion. Now, what is electron affinity? My dear student, electron affinity is the amount of energy released when an electron is added to a neutral atom and the gaseous state to form a negative ion. My dear student, think of it as the atom saying thank you for the extra electron. Here is some energy in return. X the atom I when accept electron and form X negative ion and they have energy, which is electron affinity. This process releases energy, so electron affinity is usually exothermic, mean energy is given off. Example, in chlorine, accept electron and form chlorine negative ion and gas. Del H is equal to minus 349 kilojoule per mole. This is electron affinity. Now, key points about electron affinity. Dear student, the more negative the value, the higher the electron affinity. Elements with high electron affinity strongly attract electrons like halogen. Metal have low electron affinity. They prefer to lose electrons. Non-metals have high electron affinity. They readily accept electrons. Now, trains of electron affinity in the periodic tables. My dear student, across a period, mean from left to right, electron affinity increases because atomic size decreases, nuclear charge increases, greater attraction for incoming electrons. Example, electron affinity of lithium, less than beryllium, less than boron, less than carbon, less than nitrogen, less than oxygen, less than fluorine, and less than chlorine. My dear student, also note that noble gases have almost zero electron affinity because their outer shell is full. But dear student, down group mean from top to bottom, electron affinity decreases. Thus, atomic size increases, incoming electron as further from the nucleus, weaker attraction. Example, electron affinity of fluorine is greater than bromine, greater than iodine. This is a trends of electron affinity in the periodic tables. From left to right, when you cross a period, electron affinity increases, and electron affinity from top to bottom down the group decreases. Now, factor affecting electron affinity. The factor affecting electron affinity are: first one is atomic size. Now, factor affecting electron affinity. My dear student, the factors affecting electron affinity are: first one, atomic size. Is atomic size increases, electron affinity generally decreases due to increased distance between nucleus and incoming electron. The second one is nuclear charge. Higher nuclear charge increases electron affinity due to stronger attraction between nucleus and incoming electrons. The third one is electron configuration. My dear student, elements with half filled or completely filled orbitals have lower electron affinity due to stability. The fourth one is shielding effect. Increased shielding reduces nuclear attraction, decreasing electron affinity. My dear student, these factors influence an element's tendency to attract and hold onto an additional electron. Now, comparison, ionization energy versus electron affinity. My dear students, see on the tables definitions of ionization energy is energy to remove electrons, while electron affinity energy raised on adding electrons. Metal have low ionization energy and low electron affinity. Non-metal have high ionization energy, also have high electron affinity. Trains across a period, ionization energy increases across a period, in from left to right. Electron affinity is also increases across a period from left to right. Trained down group, ionization energy decreases down a group, in from top to bottom in periodic tables. Electron affinity is also decreases from top to bottom in periodic tables. Now, application of electron affinity. My dear student, electron affinity helps predict chemical reactivity of elements, formation of anions in negative ions, placement of elements in the periodic tables. Electron affinity useful in understanding electronegativity, explaining why halogen are reactive, designing materials like semiconductors. My dear student, this is all about today's lectures. My dear student, if this lecture help you, then don't forget to like the video, subscribe to the channel for more chemistry lectures, share it with your friend, and comment your question below. Thank you for listening.